In the previous session, we looked at power rule with substitution. Now here we are going to look at logarithms and exponential integration with substitution. Okay, let's solve problems. First one, integral of 9x square divided by 3x cubed plus 5 dx. Look at the denominator. If we differentiate the denominator, we get the numerator, right? So let's say u is equal to 3x cubed plus 5. Differentiate it, we get 9x square dx. So if we do the substitutions, we get du by u. And we know the integral of this is natural log of u. And if we substitute back, we get natural log of absolute value of 3x cubed plus 5 plus c. Okay, let's look at the second one. Integral of minus 20x to the power of 4 by 4x to the power of 5 minus 3 dx. Again, u is equal to 4x to the power of 5 minus 3. Differentiate it, we get 20x to the power of 4 dx. Yes. Now let's do the substitution. Minus we can take it out. 20x4 dx is nothing but du. 4x to the power of 5 minus 3 is u. And we know this would be equal to minus natural log of u, absolute value of u, which if we substitute back, we get natural log of 4x to the power of 5 minus 3 plus c. Let's do the third one. Integral of minus 8x dx by 4x square plus 3. So now here let's say u is equal to the denominator 4x square plus 3. Du would be 8x dx. Let's do the substitutions. We can take minus out. 8x dx is du by 4x square plus 3 is u. So this gives us minus natural log of u, absolute value of u, plus c. But let's keep that to the last step. So substituting it back, we get natural log of absolute value of 4x square plus 3 plus c. Let's look at the fourth one. Integral of minus 6x square dx by x cube minus 4. Again, let's take the denominator as u, x cube minus 4. Let's differentiate it. We get 3x square dx. Okay, now here's the tricky. Here we have 3x square dx. Here we have minus 6x square dx. So what we'll do is we'll write it as 3x square dx by x cube minus 4. Now let's figure out what we need to multiply this with to get minus 6x square. So we have to multiply it with minus 2. So now we do the substitutions. We get du by u, which we know is minus 2 natural log of absolute value of u. And if we again do the substitution, we get minus 2 natural log of absolute value of x cube minus 4 plus c. Okay, integral of minus 80x cube dx divided by 5x4 minus 4. Okay, so u is equal to 5x4 minus 4. Du would be 20x cube dx. Okay, so let's do the write the integral again, but with 20x cube dx. So what do we multiply it with? We multiply it with minus 4. 5x4 minus 4. And now we do the substitution. We get du by u, which is equal to minus 4 natural log of absolute value of u, and we substitute back natural log of absolute value of 5x4 minus 4 plus c. A sixth one, integral of 27x square dx divided by 3x cube plus 2. Okay, u would be equal to 3x cube plus 2. Differentiating, we get du is equal to 9x square dx, and let's do it in one shot. 9 3 is 21, so 3 we take it out. We are left with 9x square dx, which is nothing but du, and 3x cube plus 2 is u. So this becomes 3 natural log of absolute value of u, and we substitute back u with 3x cube plus 2 and plus c, constant of integration. Okay, now let's change gears. Integral of minus 16x e to the power of 4x square minus 5 dx, right? So here, if we integrate minus 16x, we get minus 16, which doesn't help us in any way. So let's take 4x square minus 5. So if we take 4x square minus 5 as u, if we differentiate it, we get 8x dx. Okay, now let's see what happens if we do the substitutions. Minus 2 we take it out, so we are left with 8x, dx is there. So we will have du, and 4x square minus 5 is u. So we write e to the power of u. And this is a form which we are very familiar with, right? So if we integrate it, we get e to the power of u. Actually, plus c will be there, but we'll write it as part of the last step. So minus 2 times e to the power of 4x square minus 5 plus c. So that is the integral of. Actually, you know what? It would be actually divided by natural log of e, strictly speaking. But natural log and e will get cancelled. They are inverses of each other. So we are left with e to the power of u. Instead of e, if there is some other constant, then we will have to write natural log of that constant in the denominator. Okay. Now let's look at the eighth one. Integral of 30x to the power of 4 by 3x to the power of 5 minus 1 dx. Okay, u would be equal to 3x to the power of 5 minus 1. Du would be 15x to the power of 4 dx. Let's do the substitutions. Here we have 15, here we have 30. So let's take 2 out, right? So what happens? We end up with 15x4. 15x4 dx is nothing but du divided by u. So 2 times natural log of absolute value of u. Let's do the substitution back. This becomes absolute value of 3x to the power of 5 minus 1, and we add the constant of integration. Ninth one, integral of 36x square e to the power of 4x cube plus 1 dx. Again, let's take u as 4x cube plus 1. Differentiating it, we get 12x square dx. 12, 3 is 36, right? So let's take 3 out. We are left with 12 inside. So 12x square dx is du. So let's write du. And we are left with e to the power of u. And if we integrate it, what do we get? we get e to the power of u. So that, and remember, divided by natural log of e, which cancels out. So this will be equal to 3 times e to the power of 4x cubed plus 1 and constant of integration plus c. Okay, 10th one, integral of 40x cubed e to the power of 2x to the power of 4 minus 1 dx. So u is will be 2x to the power of 4 minus 1. Du would be 4 to 8x cube dx. Okay. Now, x cube is there here, 40x cube is there. So let's take 5 8's 40. So let's take 5 out. 5 times 8x cube dx. So let's write du. And this will be e to the power of u. So this becomes, if we integrate it, we get e to the power of u by natural log of e, right? The base part of it. And these two cancel out. It's better if you write it and cancel it, so that you get used to it. Okay, so we end up with 5 e to the power of 2x to the power of 4 minus 1 plus c. Okay, 11th one, integral of 20x cube e to the power of x to the power of 4 minus 5 dx. So again, u would be x to the power of 4 minus 5. Du would be 4x cube dx. Let's do the substitution. We have 4 here, 20 here. So let's take 5 out. 5 4 is 20, right? So 4x cube dx would be du, and this would be e to the power of u. So we end up with 5 e to the power of u, which is 5 times e to the power of x to the power of 4 minus 5 plus c. Okay, 12th one, integral of 24 x e to the power of 4x square plus 3 dx. So as usual, u will be 4x square plus 3. Du would be 8x dx. 3 is 24. So let's take 3 out. We are left with 24x dx. Sorry, we are left with 8x dx because 3 has gone out. So we can write it as du, and this becomes e to the power of, if we integrate it, we get e to the power of u, which is nothing but 3 times e to the power of 4x square plus 3 and plus c. 13th one, okay, integral of minus 15 e to the power of 3x dx divided by e to the power of 3x plus 2. Okay, now let's take the denominator as u. So u becomes e to the power of 3x plus 2. Differentiate it, we get e to the power of 3x as it is times derivative of 3x dx, which is equal to 3 e to the power of 3x dx. Now here we have 3, here we have minus 15. So let's take minus 5 out. We are left with 3. So 3 e to the power of 3x is nothing but du along with dx, of course, divided by this would be u. So if we integrate it, we get natural log of u, and again if we do the substitution back, we get minus 5 natural log of absolute value of e to the power of 3x plus 2, and without fail plus c. So that is the result. Okay, 14th one. Okay, now integral of minus 5 cosec minus 5x cot minus 5x times e to the power of cosec minus 5x dx. Looks funny, right? But remember, the moment you look at this, you should realize that if you differentiate cosec, you get minus cosec cot, right? Which we have. So which means we can take u is equal to cosec minus 5x. If we differentiate it, we get minus cosec minus 5x cot minus 5x times minus 5, because we have to differentiate, minus 5x dx, right? And this minus and minus will cancel, and we'll be left with 5 cosec minus 5x cot minus 5x. So let's see what happens. Let me actually write it off now. 5 cosec minus 5x cot minus 5x dx. But here we have a minus sign. Here we don't have. So let's take this minus sign out. So we'll be left with 5 cosec minus 5x cot minus 5. So which is nothing but du. And here we have e to the power of u. If we integrate it, we get e to the power of u, and we substitute u back. So cosec minus 5x plus c. So that is the integral of this. 15th one. Integral of e to the power of 3x times 3 times 5 to the power of e to the power of 3x plus 4 dx. Remember, this plus 4 is along with e, not along with the exponent. Okay, so let's take e to the power of 3x plus 4 as u. If we differentiate it, what do we get? We get e to the power of 3x as it is, and then we have to differentiate the exponent. So 3 dx. But we have this. So 3 e to the power of 3x dx we have. So which means we can write it as 5 to the power of u du. And what will this be if we integrate this? We get 5 to the power of u. Remember, e to the power of u, e to the power of u as it is. So here instead of e we have 5. So 5 to the power of u divided by natural log of the base, that is 5. And here we don't have to put the absolute value. Why? Because 5 is a positive number we are given. Okay, if it is a variable, then we should put a absolute value sign. So now let's do the substitutions back. 5 to the power of e to the power of 3x plus 4 divided by natural log of 5 plus c without fail. Okay, that is 15th one. 16th one now. Integral of minus 30x dx divided by 5x square minus 3. U will be 5x square minus 3. Du would be 10x dx. And here what do? We have 10x here. Here we have minus 30x. So minus 3 we take it out. So we'll be left with 10x dx, which means du by u. Minus 3 natural log of u, which will be minus 3 natural log of absolute value of 5x square minus 3 plus 17th one. Integral of 2 by x times minus 3 plus natural log of 5x. Okay, so what do we do here? Let's do this. Let u is equal to natural log of 5x, this part. Then what happens? Du is equal to, this will be 5x and then we have to differentiate 5x. So we get 5. 5 cancels. We are left with 1 by x dx. Right? Now 1 by x dx, 1 by x dx is there. Now instead of 1 we have 2, but 2 if we take it out, we are left with 1. So which means this becomes 2 integral of 1 by x dx is nothing but du. And this becomes minus 3 plus u. But again, this is something that we are not very comfortable with. So which means what do? We again do substitutions. We say s is equal to u minus 3. So ds will be du. So let's do this. Du is nothing but ds divided by, and u minus 3 is nothing but s. So which means now this is we are familiar with. So this becomes natural log of s. Now we have to do the substitutions backwards. So s is nothing but u minus 3. Remember we did twice substitutions. So which means again we have to do substitution. So u is what? U is natural log of 5x. So natural log of 5x minus 3. So you have to natural log of absolute value of natural log of 5x minus 3. And without fail plus 3. Okay, 18th one. Integral of minus 15 cosec square 3x times 4 cot 3x dx. Again, the moment you look at this, you know that if you differentiate cot, you get minus cosec square. So let's take u is equal to cot 3x. So du would be minus cosec square 2x and times 3 dx. Yes, which we can write it as minus 3 cosec square. This is 3x dx. So here we have minus 3, here we have minus 15. So let's take 5 out so that we are left with minus 3 cosec square 3x, which is nothing but du. And 4 to the power of cot 3x is nothing but u. And we know how to integrate this. We get 4 to the power of u as it is, and then in the denominator natural log of 4. Again, backward substitution. 4 to the power of cot 3x by natural log of 4 plus c. So that is integrating logarithms and exponentials using substitution. That's it. Bye.